Put them and go live. Left, right, and center. It was for sure. Okay. All right, I think we back up. Let's see. Yeah, let's go here instead. Right. Okay. Okay, slight delay, but I think that's doable. All right. All right, guys. Welcome back. Sorry about that. Technical difficulties. Okay, so for those who now rejoining us, this is the 2012 paper, right? Actually, there's only one watching, so I had to talk to nobody really. Yeah, in case you're watching the 2012 paper, I had to reconnect because I was getting some delay. All right, so we're gonna try this expansion, right? This one right here. So they've given us the value of sine pi over 3 as root 3 over 2. They've given us the value of cos pi over 3 as a half. And they've told us that sine of a quarter pi is equal to cos of a quarter pi. And the value that they want us to use for that is root 2 over 2. Alright. Okay, I think things are flowing a bit better. Okay, I have a different timing on this one, though. Alright, small thing. Alright. Again, sidetrack, sorry. So they want us to find cos of 7/12 of pi. Now the thing is, they've given us pi over 3 and pi over 4. And if you were following the previous example, to get 1/12, we had to do pi over 3 minus pi over 4. In this one, how would we combine pi over 3 and pi over 4 to get 7/12? We'd add them, right? So we are required to find cosine of 7/12 pi. And MB, right? 7/12 pi is equal to pi over 3 plus pi over 4. In case anybody wants to see that, when you're adding fractions, what do we need? A common denominator. Between 3 and 4, the common denominator is 12. 3 into 12 goes 4 times. 4 by the numerator of pi will give us a 4 pi. And 4 into 12 goes how many times? 3 times, and then 3 by pi will give us 3 pi. 4 pi plus 3 pi is 7 pi over 12. So what we've just shown is how we're going to expand, or how we're going to express 7/12 of pi in order to find cosine of 7/12 of pi. So we're going to express it as cos of pi over 3 plus pi over 4. So we know from our examples we did earlier, cos of a plus b is, cos of pi over cos of a by cos of b minus sine of a by sine of b. And we can pull our values from right here. Right, so cos of pi over 3, that's cos of 60, which is a half. Cos of pi over 4 is just, well, root 2 over 2, yeah? And then we're going to minus sine of pi over 3, that's root 3 over 2. And we're going to multiply that by root 2 over 2. So 1 by root 2 will give us root 2. 2 by 2 is 4, minus root 3 by root 2 will give us root 6. That's over 4 as well. And because they have the same denominator, we could simply combine the numerators as such. And if you're feeling fancy and you want to show you could factorize that, you can do so. However, that's not 100% necessary. Alright. Okay. Right, so that's 2012. Anybody have any questions on that exam? No? Alright, okay. Better, thanks. All right, Aria. Very welcome. I'm sorry about the delay. I'm not sure what's going on with that. All right, guys, I turn on the page now. So if you have to take a screenshot, I'll give you a couple of seconds. All right, the next question up is the 2013. Was there an expansion there? I don't feel like there was. There was? Okay. It was a tan, right? That was the one tan, no, but one of the few tans we had seen, because the rest of them were like sin and cos and these things, right? Okay, so let's go. Zoom out. Right, yeah, so 2013, they happen to fit question 3 and question 4 on the same page, so we're just going to go down to where we have question 4, sorry, my bad. All right, well, I guess I could put that at the top. Okay, so this is what we had to use. All right, so that's what we have to find. So it says, given that tan of theta minus alpha is equal to 1/2, and that tan of theta is equal to 3, use the appropriate compound angle formula to find the acute angle alpha. All right. Okay, so you all trying it one time? All right, cool. All right, so we know if we want an expression, an expansion for that. All right, so tan of theta minus, that's on an alpha. All right, so that's equal to tan of theta minus tan of alpha all over 1 minus tan, sorry, 1 plus, my apologies, tan theta tan alpha. Sticking again, way. No? Sorry, give it a second. I'm trying to see if it actually showing. Alright guys, sorry about the quality. I'm not sure what I could do to fix that though. I might have to do a router reset. So after the next couple of questions I might do that. Okay, so let's see what's going on with this. So we know that tan of theta is equal to 3. So that's 3 minus tan alpha all over 1 plus 3 multiplied by tan alpha. And we also know that that is equal to 1/2. Alright, so what we could do from here is try and solve for tan alpha, because remember that is exactly what we want. We want to solve for tan alpha. All right. So what e minus tan alpha equal to 1 multiplied by 1 plus 3 tan alpha. Using distributive law, we could expand the left hand side by multiplying the 2 by everything on the inside. 2 by 3 will give us 6, and then we have 2 tan alpha. Yeah, tomorrow.
I'm gonna come for 1 to 3 first.
Tomorrow.
Yeah, I'll do the work inside.
All right, cool. And that's equal to 1 plus 3 tan alpha. So here we could simply get all of the tan alphas on one side and all of the non-tan alphas on the next side. So we could subtract 1 from both sides of the equation, and then we could add tan alpha to both sides of the equation. 2 tan alpha, my apologies. Alright, so 6 minus 1 will give us 5. 3 tan alpha plus 2 tan alpha is also equal to 5 tan alpha. And then we could divide by 5 on both sides to get rid of that. Alright, so it would look like 5 over 5 equal to tan alpha. And then we know 5 over 5 is equal to 1. So if tan alpha is 1, to find alpha, all we have to do is find tan inverse of 1. Now we know that tan inverse of 1 is equal to 45 degrees. Now let me just check something with the requirements. The acute value, tan of alpha. Alright, because we know it's also going to be equal to, if you think about your quadrants, right? Remember, tan is positive in 2 quadrants, right? Here and here. So we could also, apart from this 45-degree angle, here, we could do that whole angle there as well, but they said acute. In the question, they specified that they wanted an acute angle. Oh, sorry, my face actually blocking off somebody working down there. Ooh. All right. Okay, did you guys get that? Anybody have any questions or have any issues you want to address? That's fine.
I just cross multiply.
Okay.
I multiply the bottom by half.
Mm-hmm.
Where does that go now?
That's fine. Okay, so you multiply the bottom by half. You can multiply by 2. Did you get this though?
Yeah.
Okay, all right. Well, I'll be curious to see that particular one. All right. So it looks blurry. Yeah. Click refresh and see if that helps. Now, if it's not helping, I'll do a reset again. But if not, I'll have to do a router reset eventually and see if that helps, because yeah, it's kind of lagging. Unless anybody have any suggestions. No? All right, cool. All right, we're going again. All right, so that was 2013. So now we're going to take a look at 2014. And this is the question we did for 2014. So I'm going to zoom out. Actually, can I just keep zooming in? No, let me go on this side. What will be better? All right, so sine of pi over 6 and cos of pi over 6. So pi over 6 is 30 degrees, right? All right, so they gave us the exact values and they want us to show that cos of... They're not showing blurry? Yeah, my phone either, and 45 degrees. And we know that we could find a second angle. The second angle will be 225, but they said that they want the acute angle of alpha. I hope that clears up area. All right, if not, just let me know and I'll go back on it again. All right, the acute angle. So tan inverse of 1 is 45. It could also be 225, but the question specified the acute angle. And acute is less than 90. All right, 225, of course, is not less than 90. Okay, all right, so we have to expand this. Where will I, actually, no, let me do it across here. All right, so we can ignore that. We'll come back to that another time. See if I can try to get something resembling legible writing. All right, cos of x plus pi over 6. Okay, Arya, right, good. I'm glad you understand now. So cos of pi. So if we use that expansion, we get what? Cos of x by cos of pi over 6 minus sine of x by sine of pi over 6. From the information above, sine pi over 6 is a half. Cos pi over 6 is root 3 over 2. So here we would just get, oh yeah, it's blurry there now. I've seen it. Happened to me too. Cos of pi over 6 is root 3 over 2. Strange enough, the laptop, the phone is looking decent. Actually, the phone, no, yeah, it's coming to come. But the laptop, right, so check this, right? Basically, what's going to happen is if you multiply cos x by root 3 over 2, right, you can multiply, it's equivalent to multiplying root 3 over 2 by cos x, and then you have here. So all I'm doing is I'm rearranging which is to the front and which is to the back. Right, now here, what I could do is I could actually separate the half and make it root 3 by cos x. That's minus a half by sine x. And that will allow me to factorize the half out, leaving root 3 cos x minus sine x in the bracket. Blurry here too. What? Something eating up my... is this under the bandwidth? I don't know. You seen it okay on yours? Yes, thanks. Normal? Alright, cool. It just said it's stuck on cos x root 3 over 2. You all okay with that? All right, cool. Okay guys, so what I want you guys to do is go on to 2015. I need to do a router reset to see if I could get this thing streaming a little better. Right, so this is not detracting from your experience yet because you all are my primary concern, right? Alright. Yeah, you mean 2015. Right, so 2015, zoom out. Right, so not C. C was the what? C was action identity. Oh, this one is a quadratic. All right, so here what? Bypass that one. We'll come back and do that one. So I guess I should probably not have so much dead air, especially if it's just going to be delayed or whatever the case is. Yeah, but it's not streaming, that's a problem. Alright, cool. Yeah, it's not going up. Right, I know.